Okay, in number 28, they give us a rational function, one that requires using the quotient rule in order to figure out the derivative. So let's take a look. H of t is equal to t over t minus 2 on the closed interval 3 to 5. So let's take a look. The derivative of this. So h prime of t is going to be the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. Now I'll clean this up a little bit. We have something times 1 is itself. And finally, we have negative 2 over t minus 2 squared. And we've got to ask our two fundamental questions for critical numbers, and that is, where is the derivative equal to 0, and where is the derivative undefined? Where is it equal to 0? Well, if I take negative 2 and I put that over t minus 2 quantity squared, and I set that equal to 0 or 0 over 1, and I cross multiply, you're going to end up getting negative 2 equals 0. We know that this is nonsense, so our conclusion here is that there's none. There's no critical numbers. Now, where is the first derivative undefined? It's going to be undefined when t is equal to 2. Now, we've got a little problem, and it hasn't been addressed in any of these videos yet. But if we go back to what a critical number actually is, it's got to be something. All the things that are on your list that you're calling critical numbers have to be in the domain of the original function. So we're saying, hey, this first derivative can never be 2, but t could never be 2 even in the original problem because it's to be excluded from the domain because there's an asymptote there. So this is actually not a critical number either. So there are no critical numbers. So if I go to my chart, we're going to have a left endpoint. We're going to have a right endpoint. Our left endpoint is 3. Our right endpoint is 5. This is x. This is f of x. So if I put in 3 into the original function, I get 3 over 3 minus 2. 3 minus 2 is 1, so this is just 3. If I put in 5, I get 5 thirds. So that means the lowest point, called the minimum, is going to be at 5 thirds. And the highest point, called the maximum, is going to be at 3. So these should be our answers right here. But what do you think I'm going to do next? Grab that graphing calculator and just take a look. Okay, so y equals x divided by the chunk x minus 2. Go over to the side, make it bold, go from 3 to 5. By 1s is fine, and I think I'm just going to go from negative 4 to 4. And we're going to see some sort of opposing boomerang type of thing, but only a chunk of that. So maybe we'll just see a chunk of one of the boomerangs. Let's take a look. Okay, we have our lowest point at 5, 3. Again, we're starting from 3, 4, 5, 3. And our highest point is at 3, 3. 3, 1, 2, 3. So once again, the graph confirms the calculus. In number 30, they have us find the absolute extrema of a trig function. This is the first one of its type, so it's kind of exciting. So the first derivative of secant x is going to be sec x tan x. So I've got to find out, where does that derivative equal 0? And where is that derivative undefined? Well, I think I'm going to look at the undefined portion of this answer first, because I'm thinking, where are the asymptotes, where are the things for x that we're going to exclude? And those are going to be at pi over 2 and 3 pi over 2. So we're going to exclude everything at x equals pi over 2, because that's where the first asymptote is, and all the other asymptotes are pi units away from that. So I'm going to say plus n pi, where n is an element of the integers. So While the first derivative is undefined at these locations are also not in the domain, so these are not going to be critical numbers. Now, where does the first derivative equal 0? So if I have secant x tan x equals 0, those are like two factors each equal to 0. So I could say, okay, well, where is secant x equal to 0? And where is tan x equal to 0? Now, for this first one on the left, I'm going to reciprocate both sides. And the reciprocal of secant is cosine. And the reciprocal of 0 is undefined. So this question really says, where is cosine undefined? And I know that it never is. Now, where is tangent equal to 0? Tangent is equal to 0 at 0 and pi and 2 pi and 3 pi. So I'm going to say n pi. N is an element of the integers. So we have to consider only those critical numbers that are in this interval here. So let's see what we got. We have our left endpoint, which it's negative pi over 6, and there's really no disputing that. Now we've got our right endpoint, which is pi over 3. And there's no disputing that. It's sort of a given. Now the question is, do any of these critical numbers here fall in between negative pi over 6 and pi over 3? And I believe the only one that does is 0 pi, which is 0. So I'm going to put a 0 there, and I'm going to fill out this chart. So if I go to the original problem, the secant of negative pi over 6 is like the secant of negative 30. That puts us in the fourth quadrant, so the answer is going to be positive, and I think it's going to be 2 root 3 over 3. The secant of 0 would be, let's see, 1. And the secant of pi over 3 is 2. So now the question is, who's bigger, 2 or 2 root 3 over 3? Let's take a look. 2 square root 3 divided by 3 is 1.15. So this down here is 1.15. So this is the least, and this is the greatest. Okay, so we're going to have a minimum. I have to figure out where we're going to write this, because you know we're going to check it on the calculator in a second. We have a minimum at 0, 1, and we have a maximum at pi over 3, 2, which is the same as 60 degrees 2. So let's take that calculator out and see if that's the case. Y equals, so I'm going to have to use 1 over cosine. So 1 over cosine x. Let's go make it bold. I think you guys know the drill at this point. And I think I'm going to do this in degrees, even though it's in radians, just because when numbers show up like 60 and 30, they're just easier to understand than pi over 3. So instead of going from negative pi over 6 to pi over 3, I'm going to go from negative 30 to 60, and I'll go by 30s. And I think I'll go from negative 3 to 3 for my y's. So let's graph. Alright, well, it's a little bit hard to see in this window here, but the lowest point looks to me like it's 0, 1, and this is, the highest point is 30, 60, 2. And that's what we said. We said 0, 1, and 62. If I did one little tweak with the window, you might be able to see that better. And if I make this go from 0 to 3, I think you would see it just a little bit better. Alright, so this is 0, 1 is the lowest point, and 30, 62 is the highest point.